last week I talked about how cool exoplanets are and how we can find them and look for life there. But there's a small possibility that we won't have to travel so far to find life. Although unlikely to be intelligent, NASA has highlighted some locations within our solar system as potential habitats. So, it's time to visit some of Earth's neighbours. Before the advent of modern space travel, Venus was enshrouded in a thick layer of clouds and an air of mystery. This is because from afar, 108.2 million kilometres afar, it has a similar size and density to Earth and is made of roughly the same stuff. So it was considered our twin planet, the most likely place for us to find aliens. And then we visited it. We found that its atmosphere is what makes it so different. 96% carbon dioxide and no oxygen to speak of. This is actually similar to the early Earth, apart from the pressure. Its surface pressure is 92 times that of sea level on Earth. It's this immense pressure combined with the intense greenhouse effect caused by the CO2 that makes its surface the hottest in the solar system, at a toasty 465 degrees Celsius. This means that the possibility of finding life is very unlikely. Some scientists have theorised that it could exist in the upper atmosphere, where the temperatures and pressure are more Earth-like. Unfortunately, this is also where we find the highest concentrations of sulfuric acid. These hot, acidic conditions are what makes active exploration of Venus so difficult, and all missions that have entered Venus's atmosphere have stopped transmitting within just 2 hours. Although this doesn't bode well for the possibility of life existing there now, it is possible that Venus was habitable in the past. As Venus, Mars and Earth all were very similar at the beginning of the solar system, both Venus and Mars probably even had oceans. For Venus, this is because a younger sun is a fainter sun, so the habitable zone was closer in, with Venus orbiting right in the centre. As the sun aged, the extra insolation meant that the temperature reached a tipping point and the oceans began to evaporate. This actually increased the temperature exponentially, as water is a greenhouse gas. This continued until the surface was left barren and dry. Water isn't only important in cells, but also as a lubricant at plate boundaries. Without it, all plate movement just froze in place. The volcanoes that are vital for the carbon cycle and regulate the temperature stopped, leaving the planet as the hellish world we know today. Even if we managed to design a lander that survived for a substantial amount of time on its surface, we probably still wouldn't be able to find evidence for life, because Venus has been completely resurfaced within the past billion years, and any life that did form would have died out long before then. Okay, so since I filmed this back in May, there's been some developments in terms of Venus's presence in astrobiology research. In September, a research group published a paper announcing the discovery of phosphine on Venus, which on Earth is only produced biologically or anthropogenically. So it could be a biosignature, or it could just be a product of Venus's extreme atmosphere. The findings have recently come into doubt, but they're still really exciting, especially as it was followed by the discovery of glycine, which is the most basic amino acid, also in Venus's atmosphere. I wrote blog posts on these back at the time, and you can read those by following the link in the description. Again, these are definitely not proof of life on Venus, but it does bring Venus back into the conversation. Our next closest neighbour after Venus is Mars. Despite failures in the past, it's become a much more forgiving place to send missions to, and so has become the focus of many. Like Venus, it may once have been similar enough to Earth to harbour life. This time, however, the reason for its demise is due to its size rather than its place in the solar system. It's much smaller than the Earth, roughly half the size, which meant it cooled far quicker. This cooling meant that its originally liquid outer core solidified, reducing its magnetic field to just patchy sporadic areas. The outer core would usually create a current as it's spinning, thereby creating a magnetic field by the dynamo effect. Without this, its surface is subject to intense radiation, which poses a threat to future crewed missions and any life that could exist on its surface. In spite of these challenges, if life had begun when Mars was in its habitable period, when it may have had oceans, a thicker atmosphere and a more reliable magnetic field, some microbes could still survive today beneath the ground. This could be in cracks deep within the rock or in subsurface lakes or even caves. In 2018, scientists discovered a large, probably saltwater, lake a mile beneath Mars's south pole. It could just be supersaturated rock, although this would still be cool, as it would be one of Mars's only sources of liquid water. But if it is a real lake, it could be a habitat for life. It would have to survive extremely salty conditions, but we do know of halophilic extremophiles on Earth. More research is needed, but this is a really exciting possibility. Mars is probably the most likely place in the solar system to be home to extraterrestrial life, which is why most probes that are sent to Mars are equipped with some sort of astrobiological equipment, often either to look for chemical biosignatures of present life or analyse rocks for traces of fossils of past life. Due to the amount of missions that we have sent there over the years and plan to send in the future, we need to be really careful of contamination, because we don't want to find evidence of life 2.0 and find out later that it was just the remnants of someone's sneeze. Realistically, however much we want it to be, the moon isn't a prime candidate for life due to the fact it has little atmosphere, no magnetic field, and its only water is trapped in rock or within ancient ice. But like many places in the solar system, there is a small possibility that life could have existed long ago, when for a short time after its formation, it had volcanic activity, a substantial atmosphere, and probably not a magnetic field, but it was more habitable basically. If life formed then, or was transferred from Earth via panspermia, and some survived against the odds, it would have to be deep underground, or in lava tunnels maybe. Despite the incredibly low likelihood of organic life existing on the moon, it is possible that artificial panspermia might have occurred during previous missions. It's already been proven by experiments on the International Space Station that hardy tardigrades can survive the harsh vacuum of space. And it's not too inconceivable that some accidentally hitched a ride on the Apollo program and were dropped onto the moon. It would be pretty unlikely, but still possible. And if we check back in a decade, perhaps we'll find more than microbial life on the moon, as by then, fingers crossed, NASA's Artemis mission might have started, and we might have set foot on the moon once again.